random variable is random or deterministic? Tell me.
Random variable. I think it's random only, sir.
Okay. And it is variable or constant?
It should. We are using function, so it should be variable only.
So random variable is deterministic and constant. Since it is a function, so we can determine. Random variable is a function, so we can determine. So it is a deterministic, and it is giving a constant value to a particular sample value. So it is a constant also. So try to give the proper example, because a random variable, you will think it is random and variable both, but it is not that much. And this type of question always asked in the interview. Many of my friends told me. Okay. Second thing is, what is random process?
Random process means a function which is called as some random variable will vary with respect to time as well, sir.
Okay.
So that can be considered as the random process.
Any example regarding random process?
Noise, sir. I think we can take the example of noise.
Yeah, I am using audio signal. It is also a random process. So why are you saying always noise? I am using anything which is used in communication, something like that, random process, because we don't know about the outcomes. Okay. Then tell me, what is the benefits of using BPSK, binary phase shift keying, over QPSK? Sorry, why we use QPSK over BPSK? You know QPSK, quadrature phase shift keying?
Yes, sir.
And BPSK, binary phase shift keying? What is the advantage of QPSK over BPSK?
Bandwidth constraint, the first thing is.
Bandwidth. What is the bandwidth of QPSK?
It's RB, sir.
And what is the bandwidth of BPSK?
2 RB, sir. Like 2 into the baud. 2 RB.
Okay. So bandwidth of QPSK is lesser.
Yes, sir. That's why we are going, sir.
And bandwidth of BPSK is larger.
BPSK, yes, sir.
Both have same bandwidth.
Same. Okay, sir. Then
it's a basic question. Both have same bandwidth. QPSK has also RB and BPSK also have RB. Both have RB. ISI free minimum bandwidth. If anyone is asking bandwidth, you should give minimum bandwidth. And minimum bandwidth for that is RB and RB. Then what is the main reason behind this?
Behind this, bandwidth.
You know probability of error,
sir.
Yeah.
Yes, sir.
Okay,
then the probability of we are going for higher error to reduce the probability of error.
Okay. So what is the probability of error for QPSK?
Can I write? I'll write.
No problem. You can derive it. You can write it. You will take some time. And you always derive it. In the interview, you always derive it. They will know that you have not remembered the thing. You have realized the concept. So always derive in front of them. Okay? This is the good thing. If you don't know, then you can say anything that I don't know, sir. I have not memorized that thing. Sir, I am not unable to recall. But don't waste time to interviewer. Okay? This thing also you have to keep in your mind. Okay? Then derive it.
Just remembering small things, sir. I think currently I'm unable to recall.
Okay, no problem. No problem with that. Are you comfortable with analog communication?
Yes, sir.
What is pre-emphasis and de-emphasis?
Sir, these pre-emphasis and de-emphasis is the processes which we are in for getting the signal to noise ratio. Usually, sir, the signal to noise ratio at the higher frequencies are comparatively lower than the lower frequencies. Sir. So, by using this pre-emphasis and de-emphasis, we will boost the SNR at that particular frequencies. During the pre-emphasis, we'll boost, and during the de-emphasis, we'll retrieve our signal back.
We are boosting frequency or we are boosting the value of amplitude?
We are boosting the amplitude only, sir.
Amplitude. That means the higher frequency SNR will increase because of pre-emphasis.
During the transmission only, it will it will increase. It will increase, sir.
Before modulation, you will apply pre-emphasis, or after modulation, you will apply pre-emphasis?
After modulation only, we will going to apply the pre-emphasis, sir.
No. We will apply pre-emphasis before modulation.
Sorry, sir.
And de-emphasis you will apply after modulation, demodulation, or before demodulation?
Here we are using before the. There also, I think we should have to use before the demodulation.
Before demodulation is
Sorry,
modulated signal.
After demodulation.
If you think like this and you will give the answer, they will be very happy. The interviewer will be very happy because you are applying some mind, some concept. Okay. Now, how we will get rid of image frequency? Is there a possibility to get rid of image frequency? You know image frequency?
Yes, sir. It will be used in operator and receiver. Okay. It is the disadvantage of operator.
It is unwanted signal or wanted signal? Desired signal? It's
not desired, sir. Image frequency.
Unwanted signal.
Unwanted signal. Sir. We should.
So how we will get image frequency components?
By using that relation of.
So tell me any other subject you can give the interview.
Control, sir. Control system.
What is gain margin and what is the its advantage?
Gain margin, from point of view, like up to what extent we should apply the inputs, sir. Like maximum point at which the system should be stable, sir. The system must be stable. That is the point.
So if I am getting gain margin of 5 dB or 10 dB, what it means?
Since the gain margin is positive, so it means the system is stable, sir. Stable. It will it's a measure of stability.
Okay, that's good. If I'm getting gain margin of minus 5 dB, what it means?
It means the main gain margin based on the positive or negative, we can say the system may be stable or unstable, sir. Which means the system is going to be unstable. Negative. It has also some
means that you have to add that much of DC gain in that gain. Then it will be stable. If gain margin is 5 dB, so I can add 5 dB DC gain in that system, and that system will be stable. Okay. It is not for stability only, it is also for how much DC gain we can add extra. What is minimum phase system and non-minimum phase system?
Minimum phase system, all the poles and zeros should be left side of the left side of this
S-plane.
Yes. Yes, sorry, so left side of the
imaginary axis of S-plane. Okay, no problem.
Yes, either one pole or one zero came to the right side of the S-plane, then it should be non-minimum phase.
If pole lies in the right hand side plane, what will happen?
Pole in the right hand, sir, first thing we know, like stability will not stable, sir.
Unstable.
Unstable. Sir.
If zero is in right half S plane, what will happen?
0
in the right half S plane?
I think that doesn't affect the stability, sir.
It will not affect the stability.
Yes,
Good.
sir.
Then what is the value of gain margin and phase margin in that case? If 0 is in the right half S plane,
Sir.
if 0 in the right half S
Right.
plane, then what will be the stability criteria for gain margin and phase margin? If 0 in the right half S plane, I'm telling you, if 0 in the right half S plane, for stability or gain margin should be negative.
That doesn't carry, it should be negative, sir, because
So I'm going to tell you, non-minimum phase system has two types. You are staying correct. It has pole in the right hand side or 0 in the right hand side. If pole in the right hand side, it is unstable. If 0 in the right hand side, it is stable.
okay, sir.
No problem with that. And that system is known as non-minimum phase system. And that system has, for stability, gain margin should be negative and phase margin should be negative.
For stability,
Gain margin should be negative and phase margin should be negative.
I think I didn't get you, sir. Like for the
For non-minimum phase
system,
if 0 in the right hand side S plane, then for stability, gain margin should be negative and phase margin should be negative. I think you don't know about this.
Yes, sir. Just now.
Okay, no problem. What is zero crossover frequency?
Zero crossover frequency, sir. It is the frequency at which slope crosses that 0 dB, like 0 dB.
Gain is 0 dB. At that frequency, gain is 0 dB. Okay.
0 dB.
Or gain magnitude is 1.
Yes.
Okay, no problem. Is this a bandwidth? Zero crossover frequencies represent bandwidth?
No, sir. Zero crossover frequency. No, sir. It won't represent the bandwidth, sir.
It will represent a bandwidth. There is two types of bandwidth. One is zero crossover bandwidth or one is 3 dB bandwidth. Okay.
I think 3 dB bandwidth is the only bandwidth.
You know only 3 dB bandwidth, so I didn't ask 3 dB bandwidth. I asked zero crossover bandwidth. Okay.
Thank you.
Okay. Good. Well, you know lag compensator.
Yes, sir.
And lead compensator.
Yes, sir.
What is the pole zero location for lag compensator?
For lag compensator, in the left of S plane, first 0, and then like I think first it will come like first one is the lag compensator, sir. Second one is the lead compensator, sir.
Okay, good. Will you design bandpass filter using lead compensator and lag compensator?
Yes, sir.
Design. No, I'm not asking circuit. It's okay. I'm asking about the pole zero location.
Pole zero location.
One second. Good, good, good.